So today, the last couple days we've just been talking about parallelograms. So remember, a parallelogram is a quadrilateral with two sets of parallel sides. That being said, the last couple of sections we've learned, okay, if it's a parallelogram, we also know that opposite sides are congruent, opposite angles are congruent, consecutive angles are supplementary, and the diagonals bisect each other. We know all of those things. Today we're going to talk about specific types of parallelograms. We're going to talk about rhombuses, rectangles, and squares. So keep in mind, all of these are parallelograms. A rhombus is a parallelogram. A rectangle is a parallelogram. A square is a parallelogram because they have opposite sides parallel. Okay? But you can get a little more specific instead of just calling it a parallelogram. If it is a parallelogram with four congruent sides. So you know with a parallelogram, you know opposite sides are congruent. That was one of the theorems we learned. But if it's a rhombus, all four sides are congruent. And I think if I hadn't given you a picture, you might be thinking, well, a four-sided figure with four congruent sides is just a square. But now you see the picture. It doesn't have to be a square. It can be a square, right? A square has four congruent sides, so technically a square is a rhombus, okay? But a rhombus has four congruent sides. A rectangle is a parallelogram with four right angles. Now, I think normally whenever we think of a rectangle is we think, okay, these sides are the same and these sides are the same. Notice that whenever it says, when it's talking about the definition of a rectangle, it doesn't talk about the sides, it just says it's a parallelogram. Because we know if it's a parallelogram, we already know the opposite sides are congruent, so it doesn't have to say that again. We just have to say, okay, it has four right angles. And then a square kind of combines those both together into one figure. It's a parallelogram with four congruent sides and four right angles. Okay, now your three theorems that you copied down, the first two talk about rhombuses and then the diagonals of a rhombus. Now keep in mind that for any parallelogram, the diagonals bisect each other. For any parallelogram, any of these, anything that's not one of these, any parallelogram, the diagonals bisect each other. If the parallelogram is a rhombus, the diagonals are also going to be perpendicular. Okay, so if it's a rhombus, the diagonals are perpendicular. And then theorem 614 says if a parallelogram is a rhombus, then the diagonals are also going to be angle bisectors. Okay? So they're going to bisect each other into two congruent segments, but if it's a rhombus, they are also going to bisect the opposite angles. Okay? And then if a parallelogram is a rectangle, then the diagonals are congruent. So a lot of information that's super similar, we got to keep them separate. So in a rectangle, the diagonals do bisect each other. So I know that this is congruent to this, and this is congruent to this. But if it's a rectangle specifically, the whole diagonal itself is congruent to each other. Okay? So one of the things we're going to be doing today is looking at pictures and deciding what is the most precise name for each quadrilateral. So probably the least precise you could get would just be calling it a parallelogram. Okay? You can have a parallelogram that's not any of those. Okay? Then, kind of on the same level, you could have a rhombus and a rectangle, okay? If it's a rhombus, it's also a parallelogram. If it's a rectangle, it's also a parallelogram, but I couldn't go back the other direction. And then probably the most precise, the most specific you could get would be a square. So if you look at something and you're like, oh, that's a square, but it's also a rhombus, you'd want to say square, because a square would be a little more restrictive, a little more specific than a rhombus, okay? So this first one here, if you look at the picture, it has all four sides marked as congruent. So we have two different quadrilaterals that have congruent sides, four congruent sides. We have a square and we have a rhombus. Okay? So if we can be the most precise, we want to call it a square. Can you call this a square?
No.
Why not? Not 90 degree angles, right? So this would be a rhombus. Now the next one, okay, we have these two sides are congruent, but here's the thing. This side is going to be congruent to this side, and this side is going to be congruent to this side, so I actually have four congruent sides. And it tells me that this is a 90-degree angle, which is then going to go ahead and make all of them a 90-degree angle. So I have a quadrilateral with 4 congruent sides and 4 right angles, which would make this a square. And this last one says that I have opposite sides congruent and parallel, which means it's a parallelogram, and that's a 90-degree angle, which kind of like that one. I'm going to go ahead and fill in the rest of those 90-degree angles. So what would this one be? A rectangle. A rectangle. Yes. So, okay, wanted to go through the congruent sides. Okay, let me think about this. I have to think about that and come back to that. I was going to say parallel lines, but we don't know the parallel. I maybe should have said here, you know what I should have said here? I'm going to change this. Instead of quadrilateral, let's say parallelogram. Let's say parallelogram, because then I can say the sides are congruent. Let's do that. That would make me, until I come back and look at that. Okay? All right, and then the other things you're going to be doing today is filling in measures of numbered angles in a rhombus. So I have a rhombus here. So remember, a rhombus is a parallelogram. Okay? So I know, since it's a rhombus, all of the sides are congruent. And then I also know that the diagonals are perpendicular bisectors. I only have one diagonal. What else do the diagonals do? Okay, bisect these angles, right? So this diagonal is going to cut that angle in half and cut that angle in half. So what I'm looking for here is I'm looking for the measure of angle 1, the measure of angle 2, the measure of angle 3, and the measure of angle 4. Now I know angle Q is 104. We just said that angle 1 and 2, okay, if that diagonal cuts those in half, what do you know about angle 1 and angle 2? They're congruent. They're the same, right? If it cuts it in half. So if I knew what this is, I could just divide it by 2. How are we going to find out what that big angle is? Yeah. Your consecutive angles are supplementary. So 180 minus 104. This entire angle right here is going to be 76. Which means if you cut it in half, you would get 38 for angle 1 and angle 2. What do you think, DJ? Because they're what? Oh, hey, that's interesting. But isosceles triangle. So you know that if these are congruent, the opposite angles are congruent. You could totally do that. Now that doesn't make 1 and 2 the same. It would make 1 and 3 the same, right? Which is going to end up being true. Now, if I want to apply the fact that this is a parallelogram, if this angle is 76, what's this big angle over here? 76, why? Opposite angles are congruent. So if that big angle is 76, this diagonal is also going to cut that in half, and over there when you divide 76 by 2, you still get 38. So interesting application there. All right, questions on that? Okay, let's get this glued into page 9. This is section 6.4, properties of rhombuses, rectangles, and squares. All right, so the first thing we're going to do, we did this on that left-hand side. We're going to be finding the measures of the numbered angles in each rhombus. So, number 1, when you're drawing a rhombus, all 4 sides should be congruent. I know you'll be super surprised, but I'm not the greatest at drawing a rhombus. There we go. That was a good rhombus right there. Okay. Okay, we're going to have 3 numbered angles here. So we're going to have this top angle is going to be 1, The bottom left one in that triangle is going to be 2, and then up here will be 3. Those are the ones we're looking for. And then I'll tell you that this bottom angle down here is 118. So I want to find the measure of angle 1, the measure of angle 2, and the measure of angle 3. So starting with the measure of angle 1, how will I know what the measure of angle 1 is?
118.
It's an opposite angle. Yeah, I see the hand motions there. It's opposite, which means
118.
it's 118. It's congruent, so it's going to be 118. Now, angle 2. Since this is a rhombus, what does the diagonal do? It cuts that angle in half. So if I can find this angle divided by 2, you would get angle 2. So how am I going to find the big angle? Probably a simpler thing is if you were to find just like the whole angle, these are consecutive, right? So these add to be 180. So 180 minus 118 would give me 62. Now keep in mind though, that means this entire angle here is 62. So half of that would be 31. Now keep in mind that this angle and this angle are congruent, and so if you cut that angle in half and get 31, guess what happens when you cut that angle in half? You also get 31. Okay, number 2. Okay, another rhombus here. Go. And for this one, we're going to have both diagonals. And my numbered angles, this middle one on the bottom is going to be 1. The bottom right in that triangle is 2. Up here is going to be 3. And over here is going to be 4. And we will start with this angle down here is 32. So 4 angles I'm looking for: the measure of angle 1, the measure of angle 2, the measure of angle 3, and the measure of angle 4. Now, starting with the measure of angle 1, you should be able to find the measure of angle 1 without doing any calculating whatsoever. Luke?
It's 90.
It's 90. How do you know that so fast?
Because theorem 613 says that if it is a rhombus and basically the half mountain.
Exactly. Theorem 613 says the diagonals of a rhombus, which they tell me it's a rhombus, are perpendicular, which means the measure of angle 1 is 90. Now let's move on to angle 2. How could I find the measure of angle 2? What do you think? Okay, so this is a triangle, right? I know 2 angles of a triangle, so I can find the third. So 90 plus 132 gives me 122. I know all the angles together add to give me 180. So 180 minus 122 gives me 58. Now, kind of like we did in the last one, if this angle right here is 58, what's angle 3 going to be? It's going to be the same thing, because these angles, the big angles are congruent and they're cut in half on both sides. So if half over here is 58, half over here is also going to be 58, kind of by the same idea. If this is 32, what's angle 4? 32. Okay, questions on the rhombuses? Okay, now we're moving on to rectangles. So this says LMNP is a rectangle. We want to find the value of x and the length of each diagonal. Now, before we start on this one, when you get to these ones on your homework, they're not going to give you a picture. And you don't have to have a picture to solve this, but this is a good place to address this. If you were going to draw a picture here, when you label the vertices, it doesn't matter where you put L. You could put L at any corner. It doesn't matter. Okay? But here's the thing, if you put L right here, M has to go here or here. Because you have to go in order around the rectangle. It doesn't matter if you go clockwise around the rectangle or counterclockwise around the rectangle, but you could not put M over here. Okay? You have to go L, M, N, P, or the opposite direction. That makes a difference because when they give us my information on number 3, they're going to tell me that L, N is 5x minus 8. And MP is 2x plus 1. So it makes a difference because if you label your rectangle this way, LN is the diagonal. If you were to label it the other way, it would give you a side, which is not what they're intending to do. And MP is going to be the other diagonal. And what do we know about the diagonals of a rectangle? They're congruent, right? The diagonals of a rectangle are congruent. So I can set these equal to each other. 5x minus 8 equals 2x plus 1. And to solve for x, get your x's on the same side, so subtract 2x. So we have 3x minus 8 equals 1. Add 8, we get 3x equals 9. Divide by 3, we should get x equals 3. Now if you look back at the directions that said find the value of x and the length of each diagonal, how am I going to find the length of each diagonal? Plug it in. Do I need to plug it into both? No. Why? They're congruent. They're the same, so just pick one of them. So I might do the second one because it's a little bit easier. So we do 2 times 3 plus 1, which would be 6 plus 1, which would give me 7. And let's do one more of those. Number 4 says LN equals 3x plus 5, and MP equals 9x minus 10. So, same idea. They give me both diagonals, and just like the last rectangle, the diagonals of this rectangle are congruent. So I know 3x plus 5 has to equal 9x minus 10. So to get my x's on the same side, I would subtract 3x from both sides. So 5 equals 6x minus 10. And when you add 10 to both sides, you're going to get 15 equals 6x. But you're thinking ahead, you're like, well, I probably did something wrong because it doesn't come out evenly. You didn't do anything wrong. You're just going to get a decimal, which is 2.5. You get there. And then to find the length of the diagonal, just pick one of these. It doesn't matter which one. LN maybe has a little bit smaller numbers, so that might be the one I go for. So we're going to do 3 times 2.5 plus 5. 3 times 2.5 is 7.5 plus 5, which is 12.5. Okay, questions on that one? Okay, so this one as well, determine the most precise name for each quadrilateral. Okay, so number 5, we're going to draw a 4-sided figure, a quadrilateral. Okay, looks kind of like that. And we're going to mark it so that the left side is parallel to the right side and the top is parallel to the bottom. And the top is 4, the right is 3, the bottom is 4, and the left is 3. So remember, you want, it may be more than one thing, maybe it's not, but you want to go for the most precise name you possibly can. So there's 4 options here. The most broad term would be parallelogram, and then rhombus, rectangle, or a square. So if you start maybe at the most precise, is this a square? Definitely not a square, right? Because the sides are the same. Is it a rectangle?
No.
I mean, it does have opposite sides congruent and opposite sides parallel,
Angle.
but the angles, right? Even if it looks like they're 90 degrees, which I know looks a little bit off, but even if it looks like they're 90 degrees, if they don't tell you it's 90 degrees, you cannot assume that it's a 90 degree angle. Okay? Is it a rhombus? Rhombus would have to have 4 sets of congruent sides, so no. Okay? So what is it? It's just a parallelogram. Parallelogram. Okay, number 6. We'll do kind of the same thing here. Okay, the top is going to be parallel to the bottom. The left is parallel to the right. And this time I'm going to throw the little squares in the corners. So, for this one, if we kind of start at the most precise name, could it be a square? I mean, it looks like a square. But it looks like a square. But it looks like a square.
You can't judge it by the looks.
You can't assume that, right? That's not one of the things we can assume. I can't assume that the side lengths are congruent. They don't tell me that. So I can't assume it's a square. What about a rectangle? Remember, a rectangle is a parallelogram. This is a parallelogram with 4 right angles. That's what this is going to be, a rectangle. Okay, and then the last ones, where this one we are looking for the most precise name. For this one, we are looking for any quadrilateral that fits the description. List the quadrilaterals that have the given properties. So number 7, we have 4 different quadrilaterals: parallelogram, rhombus, rectangle, and a square. So I want to know which quadrilaterals have opposite sides congruent. So out of all of those ones we have, what is one that has opposite sides that are congruent?
Rectangle.
A rectangle does, right? Okay. What else? A square does. I mean, all the sides are congruent, so the opposite sides are definitely going to be congruent.
Rhombus.
A rhombus does, because, I mean, kind of the same reason as a square. If all the sides are congruent, the opposite sides are going to be congruent. And a parallelogram, right? That's a property of a parallelogram. So it's actually going to be all of them. A parallelogram. Okay, number 8. If we do opposite angles, congruent. Opposite angles, congruent. A square does, I mean, because they're all 90, right? So, of course, a 90 degree angle is going to be congruent to a 90 degree angle. For the same reason, right? A rectangle, because they're all 90, which means the opposite angles are going to be congruent. A rhombus. Why a rhombus? I mean, because it's a parallelogram, isn't it? And isn't that a property of a parallelogram? So it's actually going to be the other two, right? It's going to be a rhombus and a parallelogram. So that has all of them too. Okay, number 9. What about the ones that have diagonals? Diagonals, congruence. What quadrilateral has congruent diagonals? No. Remember, the rhombus has perpendicular diagonals. And remember, it's the rectangle. That was that last theorem we copied down, right? A rectangle has congruent diagonals. Now keep in mind that for a parallelogram, all parallelograms, their diagonals bisect each other, but it doesn't mean they're congruent.
Couldn't that also be a square?
It would be a square, because a square is a rectangle, and if a rectangle has congruent diagonals, then a square is going to have congruent diagonals. Okay? And last one here, diagonals bisect opposite angles. The diagonals bisect opposite angles. That was the rhombus, and that was going to be that other theorem we did, a rhombus. Anything else? Now, if we think, okay, so a rectangle, if you might think, okay, a rectangle, I'm going to get like super obnoxious here and draw a rectangle. This is a rectangle, right?
Yeah.
Okay, if you do the diagonals here, do those look bisected?
No.
Yeah, no. Rectangle, the diagonals don't bisect. They're congruent, the diagonals are congruent, but the diagonals don't bisect the opposite angles. You can do this like a parallelogram, they're not going to work either. Square. A square would work. Because a square is a rhombus, and if a rhombus has diagonals that bisect opposite angles, so this is square.